Errors and flight anomalies occur every year, yet high-powered rocketry historically maintains an excellent safety record. This is only possible if the time-tested safety rules are followed. Remember that the federal government controls all of the airspace across the country, and our right to fly in that space is limited by our duty of safety to others. First Nations Launch works in partnership with the Tripoli Rocketry Association. They ensure range and motor safety. Without their supervision, we would not be able to handle high-powered rocket motors or launches. So be sure to pay close attention to the following safe practices and follow these rules carefully. The National Association of Rocketry continually reviews and revises safety rules based on thousands of flight reports, just like the ones that will be filed for your launch. Research by the NAR Safety Committee has identified some key patterns in rocket flight safety. The average failure rate of high-powered rocket launches is 8.5%. 3/4, 75% of these failures involve recovery system failures. The deadliest failures involve ballistic impacts near people, burn injuries from ignition malfunctions, and range grass fires. That's why there are 5 extinguishers on the launch pad. Other launch failures include motor CATOs, catastrophic takeoffs, unstable flight, separation failure, chute failure to open, and lawn darts, where rockets go up and come back down nose first without any stage separation or braking. For all these reasons, it is important that you make safety an essential practice and discipline throughout your rocketry experience. This includes safety at your home college during construction. You should know and adhere to your school safety guidelines. They will cover handling of tools, electrical devices, storage of engines and energetics, and toxic fume policies for chemical epoxies and paints while building your rocket. Safety also includes safe traveling to and from the competition. The most important thing to remember is that safety, like success, involves good planning. The most common dangers and failures involving rockets are preventable. Let's look at a few of them, starting with structure, then flight stability, and then motors. Before you will be allowed to launch your rocket, it will undergo a detailed safety inspection. The physical structure of your rocket needs to easily withstand the forces of launch. Of course, you should organize all of your materials and tools, but you should organize your team and process even more. This does not happen overnight. It will be done with multiple people working on separate parts coming together in phases. It's important to keep clear records. Document who is responsible for each step in the design and build process. Rockets have failed on the launch pad because an essential step, like epoxying all of the parts, was overlooked or forgotten. You will have to work inside and outside your airframe to make sure everything is structurally sound. How will you secure your fins while ensuring they remained aligned? Examine the friction fits between rocket sections. Too tight and they may not separate as planned. Too loose and they may fall off under their own weight. Is your motor mount able to withstand the calculated thrust with a good safety margin? How many shear pins will you use? How will you secure your rail buttons? Questions like these should be answered by your team before you pick up your first tool. A lot of problems can be solved in planning. In addition to structure, you will also need to ensure that your rocket will fly a safe trajectory. Stability safety requires you to reduce the risk of having unpredictable trajectories. Use of simulation tools like RockSim will let you predict a rocket's static and dynamic stability before flight. Marking these stability points, center of pressure, and center of gravity on your rocket is a competition requirement. And it isn't enough to just run a simulation. You will have to measure, weigh, and compare your actual rocket to the simulation. And for safety purposes, you will want to explore how wind could affect stability. For instance, crosswinds move the center of pressure forward. And the aerodynamics of crosswinds can cause weathercocking where the rocket actually turns into the wind. A failure here could result in a rocket dangerously flying horizontally. Using simulations, you may find that stability may be improved by increasing the thrust ratio off the launch pad. This will require you to understand the energetic properties of your motor. It is our close association with the Tripoli Rocketry Association that allows us to use these high-powered motors. Motors vary slightly based on power, size, and brand, but the typical parts of any model rocket engine include the nozzle at one end, the propellant, a delay behind the propellant, and an ejection charge at the other end. Composite motors use a mixture of fuel and oxidizers that can provide more energy and a variety of burn characteristics. However, composites are also harder to ignite and may pose extra challenges for staging or clusters. This tube is the motor. At this end, though it is hard to see, is the thruster nozzle. The igniter is inserted through the nozzle into the core of the motor and runs all the way up to where the propellant and the delay meet. You should repeat this several times to get the feel of the inside of the motor. Propellant cylinders known as grains are stacked inside, and igniters often get snagged on the transitions, so it is important to make sure that you can fill the igniter seating all the way in against the delay. You should be comfortable with doing this long before you go out to the launch pad so that you have no doubts about securing the igniter in the right position. When the launch button is pushed, electrical current flows through the pyrogen on the tip of the igniter, causing it to burst into flame. This ignites the propellant, and the expanding gases expel the remains of the igniter out the nozzle. In this image, you can see the propellant burning quickly. It ignites from the inside toward the outside and from the ends of each grain towards the middle. When the propellant is totally burned, the thrust ends, but the rocket continues under inertia. And the delay element that also started burning the same instant the motor was ignited continues to burn as the rocket gradually slows down. The delay is also designed as smoke so that you can see where the rocket is in the sky. If it is timed correctly, the rocket will slow down and reach its apogee, the top of its trajectory, at the same time that the delay charge ignites the deployment charge. Note that if the delay is too short, the ejection charge will fire while the rocket is still moving at high speed and may cause the deployment to misfire. The deployment charge is a measured amount of loose black powder. In a single-stage rocket, it pops off the nose cone and ejects the parachute. Once the parachute opens, the rocket descends slowly to the ground for recovery. In a dual deployment, the first ejection charge separates the lower frame from the upper and launches a drogue chute to slow the descent. Then, at a programmed altitude, the main deployment charge fires, popping the nose cone and launching the main parachute. Deployment charges are tricky, so even if you cannot find a certified group in your area to help conduct a test flight, you can still ground test your deployment charges. It is important for deployment charges to be powerful enough to separate the rocket sections and eject the parachute, but not blow up your rocket. Smaller rockets often use friction fits to hold stages together, but a more reliable way is to use shear pins that snap with a reliable measured force. 3 nylon 256 shear pins require about 180 pounds of force to break. You can use an online rocketry calculator to estimate how much black powder you'll need given the size of your airframe and the number of shear pins you use. But never stop with the simulation. This is the time to do actual ground test. Start with a minimum charge and then gradually increase the size of the charge until you reach an effective range. Consider how drag and changes in air pressure will affect your rocket. How much will all the tightness of the packing of the parachute change the force required to eject it? And make sure you plan how your motor will be mounted from the top to bottom. Motor retention rigs are not usually included in kits. Some reminders about safety in the pit area. No smoking, no drinking. Remember, it is a work area. Keep your vehicles clear. And just practice care and concern for those around you. Every team must carefully run a pre-launch checklist. Most importantly, when you wire pyrotechnics, make sure all switches are off and make sure all batteries are disconnected. Then, when you switch on, practice caution and keep your face away from any pyrotechnic hotspots. During the competition, the EEE safety team will advise you on motors and safety, and once we are at the range, they will take charge of all range safety inspections and operations. Range safety includes not only persons and property on the ground, but also aircraft that may be in the federal airspace above. The FAA strictly controls high-powered rocket launches requiring waivers and notification of regional air traffic control facilities. Therefore, you cannot launch unless you are in full compliance with the Federal Aviation Regulations Part 101. One of the great advantages of the Richard Ballings State Park launch site is that we can get regular annual launch dates and have been able to keep rocket recovery within the launch site boundaries. The EEE safety team will set up safety zones and flag lines to limit access to the range. The range safety officer will inspect your rocket and approve your right to fly if it meets the duty of safety to others. The launch pad manager will determine when the range is open for launch pad access or rocket recovery. Launch pads are only accessible by 3 members of each team, and only those who are 18 or older. Everyone within the rocket's ballistic range will be warned before every launch countdown and asked to keep eyes on each rocket the entire time that it is airborne. The launch pad safety officer will oversee igniter mounting and connect all remote ignition electronics. Recovery of rockets is not allowed until permission is given by the launch pad manager to enter the range. Even then, safety dictates that you be careful recovering rockets from trees and water. Never try to recover your rocket from power lines or in the middle of a pond. If your rocket is in an unsafe location, notify the range safety officer so that your rocket can be retrieved in a safe manner. Safety is maintained when responsible people understand the risks, follow the rules, and make informed decisions to prevent accidents. The more you can do to anticipate problems and solve them in planning, the easier it will be. Many of the details you need to know are covered in our other training videos, and we will be available to help you along the way with workshops and support as needed. So stay safe, and we'll see you on the range.
The guidelines in this video are provided by EEE Wisconsin Rocketry Association, host of the First Nations Launch Program at Richard Long State Recreation Area. When launching locally, please check with your local TRA prefecture or NAR chapter.